I'm Anil Kumar, and in this video we'll describe how to represent the data. We'll also talk about terms like relative frequency distribution. The example here is travel time to the school is given below in minutes for 30 students. So that is the travel time to the school in minutes. 2 minutes, 10 minutes, 12 minutes, 15 minutes, and so on for 30 students. So these are 30 numbers representing time to school. Now we'll see how to analyze such kind of random data. Let us say it was randomly collected. Now to analyze data, we could make a tally chart. So let's begin by making a tally chart. So in a tally chart, we can have a group, you can say interval, and then number of students associated with that interval. So that gives you the tally chart. Well, the tally chart will be only the portion which I have sketched here. I've given an extension since we want to talk about many of the terms associated with the data. We'll extend it to a frequency table and then find relative frequency in this particular video. Now, as you see, the spread of the data is from the lowest number seems to be 20, and if you go through the numbers, 30 is the highest number. So what we get here is the range, which is from 2 to 30. So the range is 30 minus 2, which is 28. Now this range helps us to find the intervals, right? So the intervals, if we take intervals of 10, we can make 3 groups, right? So from 0 to 9, from 10 to 19, maybe 4, right? Okay, but that is what we could do. So in such cases, what we are looking for is groups of around 5 or 6 is good. So if I divide 30 by 5 or 6, I get a number close to 5. So we decide that we'll take intervals of 5, right? So that is how you choose the interval. Once you have selected the interval, you can now write down the time duration here, right? So we'll call intervals here. So intervals which we have selected is in time in minutes. Okay. Since the data goes up to 30, I'm thinking of taking from, let's say, it's more than 0. So what we can do is we can take 1 to 5, and then we can take 6 to 10. So we'll include 30 also in it. Okay. So that is how you could choose. We already decided the interval of 5. So we are not taking 0 in this case. Normally it's the most important number. But looking into the data, we can make a change, right? So we have intervals, let's say from 1 to 5. And since the interval is of 5 duration, let's add 5 to these numbers. Now when I'm saying 1 to 5, I'm including both the numbers on the boundaries, okay? So if I add 5, I get 6 to 10, right? And then, so keep on adding 5. So you get 11 to 15, 16 to 20. You know, next number should be one more than 20. So that's another way. 21 to 25, 26 to 30. Okay. So we have 1, 2, 3, 4, 5, 6 intervals. Now, in the tally chart, let's write down tally here and figure out how many students fall in which group, right? So that is the tally which we are going to look for. So 2 will come in the first one, 10 in the second one, 12 in the second one, 15 will go here, right? And then 20 will go here, 30 last one, 25 right there, 22, 11, 7 and 8, so 7 and 8, 16 and 26, 16 and 26, 15 and 17. 15 goes there, 17 comes here. 13, 19, 15. So when you get the fifth one, it's a good idea to cross it. It helps you to count better. So we are here, right? 15 we are taken care of. 7. So 7 goes there. 16. Okay. 27. 22. 6 and 9. 6 and 9. 16. 10. 21, 5, 12, and 9. Okay, so that gives you the tally for each interval selected. So this part is called the tally chart. Okay, so that's the tally chart, tally plot, whatever you may call, or a tally table. Okay, now from the tally chart we can get the frequency. So let me write down the frequency. Okay. Frequency is how many in each, right? How many? That is the frequency. So it's a simple addition of what you got in the tally chart. So we have 2 here. 5 and 4, 9, 5 and 6, 5 and 6, 5 and 2. It's always a good idea to total the frequency, right? That gives you an idea if we have included all of them or not. 2 and 9 is 11, 11 and 6, 17, 23, 23 and 5 is 28, and 2 is 30. So it says for 30 students, so I hope we have covered them all. Okay, good job. So that is one thing correctly done. If you get an error here, you have to redo your tally chart. That's very important. Now, once we get the frequency, at this stage, we can actually sketch a graph to represent the data. Now, what kind of graphs could you do? So let me take that up also. So at this stage, we could have a histogram. Okay, we could have a histogram. We could have a bar graph. Okay, we could also have a frequency polygon. Okay. Now bar graph is a special kind, histogram is a special kind of a bar graph. Bar graph is very general. You could make bar graph for most of the data. In histogram, the data should be continuous. So these bars are kind of continuous, joint. There are no gaps between the bars, right? That is kind of important. You cannot make a histograph if you have different kinds of data, right? For example, if you have different flavors of ice creams, you cannot make a histogram, but you can make a bar graph, okay? In this particular case, since we're talking about the time, which is a continuous thing, you could always make a histogram, okay? So we could develop or sketch a histogram in this particular case. So, okay, so let's try to make one. So let's say we take, so we have 1, 2, 3, 4, 5, 6. I want to leave some space for relative frequency also, but let's extend this video to cover the histogram part also. Okay, so what we have here is kind of 2 axes. As in bar graph, we have 2 axes. The first one here, the horizontal one, in this case, will be the time duration, right? It said travel time to school. So you could write here travel time. And the units, minutes, okay? And on the vertical side, it is how many students, or you could write frequency. So you see histogram is relating the travel time with the frequency. So that is what the relation is. Since we have the intervals clearly defined, okay, so we could take this up to 5 and then 10, 15, 20, 25 and 30. On this axis we are going up to the number 10. So let's say this is let's say we go by twos. Let's say so we have 2, 4, 6, 8 and 10. Okay, so well, these are the numbers. Let me write down few of them here. So this is 10 for us. Okay, and this is okay, this is 2 for us. As far as time goes, this is 5, 10, 15, 20, 25 and 30. Now we look into the frequency table. Now when we include frequency, the name changes. I mean this and that. The name becomes frequency table. Okay, so tally chart, if you remove this portion and just consider these two, it becomes a frequency table. Okay, now let's plot the data. What do we have? In the first group, it is 2. So this is, let's use a colored pen. Okay, so it is this one. That's the bar. 6 to 10 is 9. So 6 to 10 is 9, slightly lower than 10, correct? And then it's a good idea to use a scale so that you get vertical lines. Okay, so let us say this is our 9, okay, the second group. And then we have 6, 11 to 15, so we're just saying beyond 10 is 6. So which is this right now? Okay, 6. 6 for 16 to 20 also. Okay, so 6 for 16 to 20 also. Okay, and then we have 21 to 25 as 5. So midway. Okay, that is how it is. 26 to 30 is 2. So like this. Okay, so what we get here is these bars. So you can join them since we are referring this to a continuous data. Right. Clearly speaking, the way I wrote, it seems there is a gap. So what do you do in such cases where you really avoid the gap? Actually, to begin with, I was not thinking of sketching a histogram, and therefore I wrote the data like this. But in case you are really thinking about it, what we do is we kind of make this continuous, and I'll show you how to make this continuous. Okay, so let's get back to this. All right, since this is kind of an addition to what I wanted to do. So what you should do here is that instead of taking like 1 to 5, I'll change one of this, 6 to 10, right? 6 to 10, I could have written this as from 5.5 to 10.5. Do you see that? Right? If I kind of change interval in this fashion, then it becomes continuous, right? 5.5 to 10.5, it becomes continuous, correct? And then I could write this as 10.5 to add 5, 15.5. So now the boundaries overlap. Do you understand? So if the idea is to sketch a histogram, you should write intervals as shown in red. Do you agree with me? The tally chart is not going to change, correct? Since we have numbers which are not in decimals in this particular case, there will not be any confusion also. So this is a very important note. In case you really wanted to make a histogram, you should prefer to write the numbers as shown modified here. Okay, now that's fine now. Okay, so I hope you got the concept. So histogram is a continuous plot which looks like bars, but they are continuous, and we can actually plot a frequency polygon from here. To get the frequency polygon, what we do is we take the middle values. Okay, so we take the middle values and join them. So in this particular case, if you join these two, you get something like this, correct? Once you do that, this is what you get as a frequency polygon. So the red line here is the frequency polygon when you join the center values, right? So this is like center values, right? 2.5, 7.5, and so on. So that gives you the frequency polygon. Okay. Now, let's talk about the main topic, which is relative frequency. So let me write down relative frequency here. As you can see from the term, relative means we are relating it to the whole data, right? So what we do here is, to the numbers, we divide these numbers by total number of students. In our case, the total number of students was 30, right? So if each number I divide by 30, I get kind of percent of students which are associated with that kind of a group, right? So that is how you get a relative frequency diagram. So in relative frequency, we are talking about a part of the whole, a fraction, a percent of the data set, right? So what we are looking for is, let me write down here, percent or part of the whole or percent of data set. That is what relative frequency distribution will show us. Now here we have 2 out of 30, right? So 2 out of 30. So we'll divide each number by 30 to get decimal equivalent, right? So what we are doing here is we are dividing each number by 30. So we divide each number by 30 since the total is 30. Do you get an idea, right? So we'll do 2 divided by 30 equals to what, right? So you can use the calculator to say 2 divided by 30. Good to write in decimals, 0.066. So we get a number. Let me write down this number as 0.066. Okay, correct. So that gives you 6.6%. So if you want to read in percent, that will be 6.6% times 100. Do you understand? So that is what relative frequency table is going to give you, right? So let's go ahead, do others also. 9 divided by 30 equals to, in decimals, 0. So I'll write down the numbers here now, 0.3, right? So that becomes, let me write 30, that becomes 30%. Okay. Now next is 6 divided by 30 equals to, in decimals, 0.2. Okay. And that again will be 0.20. 5 divided by 30 equals to, in decimals, 0.166, and 2 divided by 30 equals to 1 over 15, or 0.066, as we did in the first case. So that becomes the relative frequency.